Hey everyone, so today we will be talking about Spark Structured Streaming Windows operation, right? And then we will be touching something about watermarking, which is for late coming events. And then we will jump to joins, okay? But before we jump to Windows operation, let's understand quickly what window exactly means, right? So in very simple terms, we have all the events coming in from some source. So let's say this is our source, or we can say our streaming source, right? And this is your Spark structured streaming application, right? So what exactly is going on? That these events are coming in some interval. Let's say this particular events came in 5 seconds. These events came in 5 seconds, and more events are coming in, let's say 5 seconds, 2 seconds, whatever. So now the question arises, how do we need to process these events, right? Obviously, we can process them as soon as they came. For example, once this event came, we'll process it. Let's say this is event E1. As soon as it arrives, we'll process it. This is one way. But the question is, in production environment, you do not process the event like this. What you will do in the streaming events, in most of the cases, you will create a window. You'll create a window, right? So window means what? Window means a time interval. Window means a time interval in which all the events arriving, we will consider them as one window. So let's say if our window is 5 seconds, right? If our window is 5 seconds, then these 3 events will be considered into W1, window 1. This will be considered into W2. And this will be considered into W3. If our window size is 5 seconds or window interval is 5 seconds. So now we came to know that there's something called window, and window is nothing but a time interval from start to end. So this means, let's say 11:55 to 11:60, that is 12 a.m., 12 to 12:05. Let's say our window is 5 minutes, right? Then 12:05 to 12:10. So this will be your one window. This will be your second window. This will be your third window. It means window is nothing but a time duration, and all the events which will be coming in this time duration will be considered as one batch in simple terms, and we will perform some operation on this batch, and then we will give the output, right? So now we came to know every window will have two properties, that is window start time and window end time, right? And this start time and end time will form the whole window. Simple, right? Now the question arises, what is, okay, before I go to the next question, there are two types of windows, right? So there are two types of windows. Into the first case, what I was telling you, the window is something like this. So this, let's say, this is first window, this is second window, this is third window, this is fourth window. What we can see, that none of the windows are overlapping. So let's say this is from 12 to 12:05, this is from 12 to 12:10, 12:15, 12:20. So what we can see, that none of the windows are overlapping. Everyone is independent of each other. So we will call this window where there's no overlap, we'll call them as tumbling window. Tumbling window, right? So there are two types of interval. One is called window interval. So this, in this case, window interval is, let's say, 5 minutes, right? Every window is of equal size. This is 5 minutes, this is 5 minutes, this is 5 minutes, and this is 5 minutes. One is called sliding interval. So this is your Windows interval. This is a window interval. And one is called sliding interval. Sliding interval means when do we need to create a new window? Into this case, we are creating new window every 5 minutes. And the window size is 5 minutes. That's why there is no overlapping, right? So let me draw it with different color. Let's take black color here. So this is the boundary of first window. This is the boundary of second window. This is the boundary of third window. And this boundary is created after every 5 minutes. And so what we can say here, that window size, that is window size is equal to 5 minutes, and your sliding size or sliding interval is equal to 5 minutes. And that's where there is no overlapping. And that's where we will be calling it tumbling window. So when there's no overlapping means your window size and your sliding interval, when it is equal, there will be no overlapping, and then we will call it tumbling window. But what if your windows look like this? So this is your first window. It is of 5 minutes, right? And we are starting a new window of 5 minutes, but we are starting it from here. So it means this particular section is your overlap, right? So it means into this particular case, we have window size as 5 minutes, right? And your sliding interval is 1 minute. So this is a 1 minute. Now the new window will be created here again. And this will be your overlap. So this will be your 1 minute sliding interval. This will be 1 minute sliding interval. So we are creating window every 1 minute, right? And so it means your window size is 5 minutes and your sliding interval is 1 minute. So this is how it works. So into this case, what we will be doing, we see in either case, whether the case is this or your sliding interval is 1 minute or 5 minutes, we will be calculating for one window only. For Spark, it doesn't matter whether your windows are overlapping or not. Spark will consider it as a separate window. So how Spark will work, let me draw with different color now. So how Spark will work, Spark will first take this window, then it will take this window, then it will take this window. See, calculation wise, it's very simple. It's just for the business understanding. Let's say we want to initiate a new window every 5 minutes. We want to initiate a new window every 1 minute. And in this 1 minute window, we need to see the events for last 5 minutes. So in this case, every 1 minute, there will be new window, right? There will be trigger after every 1 minute, and we will see the events which are coming in last 5 minutes. So this kind of scenario, we will be going for sliding interval is equal to 1 minute, right? So now we came to know that there are two kinds of window. One is tumbling window, in which there's no overlapping, and the sliding interval and window interval is same in the tumbling window. If sliding interval is less than window's interval, then obviously there will be overlap, and that's where this overlap will come in picture, right? So this is all about windows. Now, how to create windows into your Spark streaming application? Let's go to the code, right? So when we jump to code and we see the Windows streaming code, so what we need to do, we need to import certain libraries first of all, right? They are nothing very specific about Windows application. They are general libraries what we import in Spark streaming application. Then we will be setting some log label, right? Then we will be creating our Spark session. And then we will be reading, into this case, we will be reading from console or your socket, right? From this particular host and this particular port, okay? Now, when we talk about socket, right? When we talk about socket, one important thing which we need to keep in mind is whenever we are reading anything from socket, the default column created by Spark, when it reads any data from socket, the name of that column is value. Okay, it doesn't matter what we are passing into the string. So for example, what I'm telling you here, let's say if I'm creating one socket, right? If I'm creating one socket, let me log in here quickly. So 1 second, guys. So if I'm logging here and I'm pasting something here, so I logged in successfully. Now let me start one socket for you guys. So let's say I'm starting a socket on 6449, right? On this host, and on this port, I'm starting on socket. Okay, so this is already in use. So let's go for 6 whatever, any port. So what I'm trying to say here, for Spark, it doesn't matter what we are writing here. Even though we are writing this thing, this column will be coming in value. Or if we are writing some JSON code or JSON application, this one, this column also will be going to the one, the structure, or it will be going inserted into the table with the column whose name is value, right? Which, so in simple terms, what is going on when I'm writing on anything on console, behind the scene, virtually what Spark will be doing for us, it will be creating one table of only one column, value, and it is putting everything here. So into this case, what Spark would have done for us, so it would have copied this one here, right? And again, it copied the JSON folder here, right? JSON file here. So it means when we are reading something from console, when we are reading something from socket or console, what Spark will be doing is Spark will be creating a table only with one column. Now let's say we are giving some data to our to the socket, right? And data looks like this, right? Data looks like this. So now we came to know that you have some value column into one table, and the column value, so it's very confusing actually. The name of the column is value, and the value or the, what we can say, the content of this value column is this, right? So now what we need to do, ideally, we need to, if we want to give a structure, to this particular column, right? What we need to say, we need to split or give some structure to this column so that it can be segregated in two parts. Let's say edate. What we need now, that this particular table, so what we need now, something like this. So we have value column here. We need to give some transformation, and we need table like this from this case. So we need two columns now. One is edate and second is message, right? So we need to do some magic here so that this particular table, which is created by Spark for us when we read from console or socket, will be converted something like this. Now we know what we need to do. Now let's see how to do it. So let's go to the code. So what we did, we read the lines from the socket. Now we, as a developer, know that my line consists of two parameters or two values. One is edate and other one is message, right? So what I did, I created this struct type because I know the structure beforehand. I know that I will be getting these kind of messages from this socket. So what I did, I created this struct type with my predefined structure, edate as timestamp and message as string type. So now I know. Now what I need to do, I need to assign this struct type or schema to these lines, right? So how I can assign it? It's very simple. So there is one function available in Spark, Scala or PySpark, whose name is from JSON. So from JSON means if we are getting JSON input from anywhere, and if we want to assign schema, or if we want to split that JSON input into multiple columns, then we can use from JSON function. So into our case, what we are doing, we are using from JSON onto which column? From column value. And then we want to assign the schema, right? So we just pass this schema here. Okay, so let's forget about this part for 2 minutes. So what we did here, we called the from JSON function, and this is a SQL function. This is a SQL function. That's why we are calling using select. So on our streaming data frame, we call from JSON function using select. Then we pass the value, column name, and then we pass the schema, which is our this schema, right? And then we rename that whatever the column coming as into my column, right? Now when we do it, right, so what it will do, So till now we are clear that this is the default output or input from socket. This is done. Now what I did, I created my column, right? I created my column here, this one, and inside that my column I have assigned schema to the value column. So it will come something like this. Now if we see here, what we are seeing that after assigning the schema, it is not coming to the root level. So this is our root, like this is our root, but my column is coming inside root. What I want something output like this. So what I did here, to bring all the columns under roots, what I did, I just selected all my call.star here. So now if I run it for you, okay, let me run it for you. So first of all, let's do one thing. Let's change the port here quickly. On which port we have opened? We have opened on 6466, right? So we'll use that port here, 6466. And we will save it. And we'll do one more thing. Let's change this checkpoint directory to something, any message. And let's run it for 2 minutes, okay? And let's run it. So what I'm trying to show you here, that the first it will print the default schema from socket, then it will print the schema after I assign my predefined schema to the socket line, right? And then I will print the schema when I want to bring everything to the one level. Okay, let's see. So don't get confused. It's very simple, and you can reuse this code in multiple applications. Okay, this is how you need to prepare data when you want to test some applications. Let it run. Okay, wait for a second. I did one mistake here, so I need to run from here. So basically, I was doing something else before I started this class. Maybe it is pointing to something else. Now, if we see here, it is running my windowing streaming application, right? So let's see. Okay, so it is working now. And let me stop this for 2 minutes. So what I did, this is the schema by default, which is given to us by Spark Structured streaming. It has only one column, and let's consider table name as root. Simple. It is not a table name, but let's consider it. Now what we did, we assigned one schema. Schema is SCH, and we name that table as my table, my column. Okay. So what we did, inside root, we have now my column, this one, and inside that I have two new columns or new which came from here. Now, since I want them to be into the main table, what I did, I selected everything from my column, my call.star, and I assigned that to final df. And when I printed the final df schema, it is coming like this. So this is my final data frame. So these are the operations which we need to do if we want to give a structure to the socket input. Okay, and then since I want to show you guys that okay, how windows look like. So what I did afterwards, I did something here. Okay, so then okay, so till now everything is clear, right? How we give the operations, how we give the structure to the socket. So this one is clear, I think. So now we know that now we are doing some Windows operation and we need to create a window. So onto our final data frame, right? So we have created our final data frame, which something looks like this data frame, right? So in our data frame, we have two columns. First is edate and second is message. Now what we need to do, we need to create window. And to create the window, we need a timestamp on which we need to create the window. So what I did here, in fact, I don't want to show you this one. So what I did here, I need to do group by operation on some window. So I need to create the window first. So what I did here, I called group by, and then inside group by, I said create a window. On which column create a window? create a column on this particular column, right? And how many minutes or the size of the window is? Window size is 10 minutes. So this particular thing is the definition of our window. This is our definition for the window, this particular thing. So what we said, or what we are requesting Spark, that create a window for me on eDate column, and the window size is 10 minutes. Okay, and we put this window inside your group by operation, right? So what we did now, and one more thing, what we want to count. Okay, so before I jump ahead, let me explain one more thing. So what I want from this windowing operation, let's say if I'm passing anything onto the console, let's say I'm passing animal names, cat, dog, owl, or let's say whatever, and we are passing them, so we need to count the number of words. Let's say we pass cat again, 12:05, this is 12:05, 12:05, 12:07, this is the time, right? So, and 12:15, whatever. What we need to do, what we want from our application, that how many times particular animal occurred in that particular window. So what we said now, that create a window for 10 minutes. This is what we asked, right? So 10 minutes means windows will be like this: 12 to 12:10, one window; 12:10 to 12:20, another window; 12:20 to 12:30, another window. So let's say if this cat is occurred in 12:05, this will be in this window, right? So it will be cat and 1. Then dog is again in this window, so here will be dog and 1, something like this, right? And again, this is a 1 window. And then this owl occur at the same time, there will be owl and 1. If this cat occurred at 12:07 again, let's say, right? So it means it is again in which window? It is again in this window. So it means this cat count should be increased by 2, ideally, right? So what is Spark doing behind the scene? It should be, if we want something like this, right? If we want something like this, then this information, this particular information should be maintained somewhere, right? And we know one thing, that this information is maintained into called state store, right? We know this thing. So now let's jump to our code, and we will come to this state store in 2 minutes. Now we want to count number of time each message occurred in this particular window, and we need to count it. So what we are saying, that okay, on final df, group the final df by messages, but only group the messages which occur in this particular window, right? So what we are saying again, in simple terms, this is our final df in which we have date and message, and we want to count the number of messages occurred in particular window. So what we are telling Spark is structured streaming, that in the final df, count the number of time this message occurred in this particular window. Simple, right? So final df dot group by, and in the group by we are declaring one window. The window will be always on the timestamp column. Into our case, the timestamp column is edate. So we pass the column edate, and we tell the window's duration. And on which column we need to count? We need to count on call message, like message column. And then we have set the count, right? Now I explained in the very beginning, in Windows, we have 2 properties, window start date and window end date. So what we, from this window, if I say something like window dot, so what into Windows, what we have different stuff, right? But I want only 2 things, that is window start and window end. So when we go here, we should have window dot start. Let's see if we have that thing. It's not coming here because it is considering Windows as string, but in Windows we have 2 important feature. Every window has a start time and the end time. So what I did, I selected the window start time and the end time. Then I selected message and the count. So this message and this count from window count data frame, right? And then what I did, I just printed on our console. I did it in update mode, and then I printed it on console. Let's do one thing. Let's do complete mode here for 2 minutes, and let's save it. And yeah, so now let's change the checkpoint directory for 2 minutes as well. And now let's run it again. Okay, let's see how it works. So let's clean this console and let's run it. Now, once this will run, I'll explain you how state store is maintained, right? How Spark is taking care of state store. Let's run it in 2 minutes. Okay, so this is running and it created some batch, but it don't, because we haven't gave any messages, so it don't know what to count, right? So let's do one thing. Let's go to our windowing watermarking here, and I have created some messages. Okay, one more thing which I need to explain before I jump to windowing operation, which I missed, and it is very important that, and actually I explained it when I was starting structured streaming, right? That structured streaming will always work on event time, event generation time, to be more precise, right? So there are two kinds of time. One is called event generation time, or in simple terms, event time. So here is your source, right? This is your source. This is your destination. Into our case, source is nothing but your producer. Let me change the color. This is not looking good. Source is nothing but your producer, and destination is nothing but your Spark streaming application. And from here, your events are getting generated. Events are getting generated at some particular time. So let's say this is 12:05, this is 12:06, this is 12:07, right? So this time on which these events are generated, we call it event time, right? So this time, let's say this particular event reached your Spark streaming application at 12:06, or it got processed at 12:06. We call this at processing time, right? Processing time. So your Spark streaming application, Spark streaming, not structured streaming, will always consider this particular time, processing time. But in reality, which is more accurate? So basically, here, right, when we go from source to destination, there is network here in between, right? There is network, and this network, and because of any number of issues, network latency, maybe this device got failed, maybe n number of things, these messages might arrive at any time. Let's say this message generated at 12:05, and this message arrived at 12:15, or 12:20, 12:25, or maybe next day. So which is more reliable time? Obviously event time. And this is where Spark structured streaming researchers designed the Spark structured streaming in such a way that it will always consider event time. And that's where we are giving event time here into our window. So when we are creating the window, we always need to give the event time. Okay, so now clear, right? And now the question arises. Obviously, in your production environment, you will have your application generating event time for you, but for your testing, you can pass event time in such a way, right? So you can pass the event time in such a way. So you can say the column name eDate, which we already defined here, eDate in your structure, right? Actually, I don't want to confuse you guys. So what we did here, we created one timestamp type eDate, and then we're passing some message. So this eDate is nothing, we are mimicking your event time here. So let me copy paste this particular message onto the console, and let's minimize this, and let's go here, and let's come here. So when I hit, not this one actually, this one. Okay, in fact, let's close this. Okay, let's do one thing. Let me paste it now and hit enter. Let's see if it's working. So this is nothing. Let's minimize it. Okay, so it came, right? I pasted one message here. eDate, this one. So what we define into our code that we want a window for 10 minutes. And in each window, we want to count the number of time this message occurred. So and since we declared that we want the window for 10 minutes, what Spark structure streaming did for us, it created the window around this particular event. It created the window around this particular event. So what it did, it created one window. What the window is? From 12 to 12:10, it created one window, right? This one. And into this window, it found cat one time and it put the count here. Okay, so this is good now. Now let's say we passed one more message at 12:02. So which window this event will fall into? Into the same window, right? So let's paste it here. Here. So we'll paste it here. I don't want this. So what it will do, it will create one more event with dog and one event. Now, if you see here, the window is still the same. Window is still the same, and it is maintaining the count 1 and 2. Okay. So now let's see one more event. And this event came at 12:03. And let's paste these two events together. So what these two events are? Dog and dog again. And which window they will fall into? They will fall into 12 to 12:10 window, because 12, so this particular will come into 12 to 12:10 window, right? Simple. Now, what is the count for the previous dog? Is 1. Now, since we paste these two events here, let's paste them. Sorry. In fact, let me remove this because I haven't copied the correct word. So let me copy these two events. Okay. So I'm copying two events which generated from source at 12:03, and let's paste them here. And let's go to our streaming application. So now what it did, let it run. Okay. So what it did, it maintained the count for the previous, how many times the dog word occurred, and it added 2 here. Why? And in the same window, 12 to 12:10. So if we start from here, we haven't sent any messages, there's nothing. Then we send cat, so the count is 1. The window is 12 to 12:10. Then we send dog, so it since this is complete mode, right? So our mode here is complete, right? So what we did, Spark application did, it created one more row into the same window where the dog has count 1. Now we passed 2 more rows at 12:03. Since 12:03 is the same window, what it did, since this is complete mode, it added 2 more to the previous count of the dog. So now the count is 3. So now before I put more messages, what we are seeing here, that Spark somehow maintaining the state from which it is reading the count, and then it is adding that to that count. For example, at 12:02 we passes dog, right? So what Spark did for us, it created a window from 12 to 12:10. It added dog to it, and it added a count. Then we pass on 12:02 again, we pass a word cat. So it in the same window, 12 to 12:10, it appended this, and the count is 1, right? And then what we passed on 12:03, we passed dog again, and we passed 12 dog again. So what Spark did now, Spark check is its state store, and it renders for this word into this window. First of all, what Spark will be doing, whenever Spark will see any time, it will create a window for it. If it sees the window is already there, then it will see what word came. So if that word is already there, it will add +1 to it, and it will update it, right? So now let's see how it works. So see now, when we passed at 12:03 one dog, then it will say +1, and it came 2. Then it found the other dog, and it turns to 3. So when this particular occurred, it turns to 2. When this dog came, it turns to 3, right? So what it means, what I'm trying to prove here, that this state store is updated after every window or trigger or event. So this state store is updated. So it means it means, let's say, now let's jump here quickly. So let's say on 12:07, I passed two more events. So first of all, which window they will jump to, which window they will go to? They will go to 12 to 12:10. Very simple, because 12:07 is false in 12 to 12:10. And we have cat word already in 12 to 12:10 window, and the count is 1. And we are passing one more cat. So what it will do? It should update that particular cat to 2, and it will add one more row for owl, for this word owl, right? So let's see. So we'll paste it here, and before hitting enter, and let's go here now, hit enter. So what it will do now, it should give me 3 rows. Perfect, that's what I wanted, right? And this is what I wanted. So what it did for us, we were here, right? I entered 2 words, cat and owl. So first it encountered owl, and it found the time as 12:07. It found that, okay, this is in this window, and it added 1. Then it encountered one word as cat. Then it sees the state store that, okay, in this particular window, we already have the cat word, so I need to add it. So it means that it is maintaining the state store, and it is updating it and retrieving it and doing a number of things behind the scene for us, right? Now let's see one more interesting thing. Okay, so let's say on 12:11, we have one more event came. Just one more second, guys. So let's say this event came. So it means 12:11 is in which window? So this window is different now, right? So these particular events till here are in 12 to 12:10, right? Now this particular event is at 12:11. So it means Spark should be generating one new window from 12:10 to 12:20. And it should not update the count for this particular dog, which is 4, right? 1, 2, 3. Okay, the dog count is 3. It should not update it to 4. Rather than it should create a new window from 12:10 to 12:20 and put the dog count as 1. Let's see how it works. Perfect. So what we see here, that it didn't update the previous window, because obviously what Spark do? Spark sees the window, Spark sees the word, and then it will update it. Into this case, the time was 12:11, so it created a new window for us, and it appended dog here, and the count is 1, right? Now let's see one more interesting thing. Let's say we have one more event came, but the event time is 12:04. What it means? That this event 12:04 event, this is interesting, and listen to it very carefully. This particular event was generated at 12:04, but because of any network latency, any kind of issue, it reached the destination after this event. So basically, when we see here our rows, we have reached till 12:11, right? So it means we have reached till 12:11, but this particular event, which occurred at 12:04, reached the destination late. So let's say what I'm trying to show you here. So let's say we are pasting it here, right? So 12:04 event, we pasted it here. It means it arrived late. So we call it as late event. We call this event as late event. Late event means what? That it occurred at certain time, but it reached the destination at some other time, which is late than its generation time. So into this case, what should happen? This is 12:04. It means this will fall in which window? 12 to 12:10 window, right? Because 12:04 should occur in between here, and 12 to 12:10 we are passing dog here. Before it we have 3. Ideally, what Spark should be doing? It should be updating it by 4. Let's see how it works. Okay. So let's go to code, and what we see here, that our dog count was 3 into this window, and the late event also got entertained, right? So it means the state information has been maintained for long, that okay, even late events have been entertained here. Now the question arises here. Let me stop this application now. one important question which we need to ask ourselves, how long we need to maintain this state information? How long we need to maintain this state information? Can we maintain it for 2 hours, 3 hours, 4 hours? It means how long we need to entertain the late coming events. So as a developer, or from asking the business, from data scientists, we need to see how long they want to entertain the late coming events, right? So if they say that, guys, we want to have events coming after 10 minutes, we can entertain them. So event which are late by max 10 minutes, we can entertain them. Or even which are coming after 20 minutes, we can entertain them. But we cannot have a system which can have events which can entertain late coming events forever, because this state information, this state store will go to any size. We don't know, right? And we don't have unlimited resources. It will be very expensive. It will make your application slow. There's so many things. And so we need to control the size of this state store by deleting previous states or previous window state. So for example, if this 12 to 12:10 window needs to be maintained up to which time, the question is, right? So let's say if this 12 to 12:10 window and the current time is 12:50, for example, we want to define something so that, okay, based on some logic, if the previous window, at which time we can delete it from the state store, so that state store can become light and empty, right? So what Spark researcher says, that to maintain this state information up to certain time, so that late coming events cannot be entertained for forever and can be entertained for only for certain amount of time, let's create a concept called watermarking. Watermarking. So what watermarking says, that please tell me how much late events you want to entertain, right? What watermarking says, that how long we can wait for the late coming events. So what watermarking says here, that let's say in each event you have a event time, right? So let's say event time is 12:50. Okay, and I want to entertain events which are 10 minutes late. I don't want more than 10 minutes late event. How watermark is calculated, the event time, this is your event time, okay? This is your event time. Now, what we define in the watermark, 10 minutes. So what Spark will do, Spark will minus this 10 minutes from this particular event time. What the watermark will come? 12:40 now. So what Spark says now, since you have defined the watermark or latency 10 minutes, what I will do, after every event, I will see the maximum time. So this is your max event time. Max event time. Max event time means what? Let's say if after this event, 12:45 event came, it will not calculate the watermark again, because it will only see the max event time. So in this scenario, what is your watermark is 12:40. What Spark says, that I won't be receiving events which are less than this. So I won't be receiving event for 12:39 or 38 or 37, anything. I can only receive events which are occurring after this, 12:41 or whatever. So this is how watermark works. So what Spark will do, we know that Spark is maintaining a state store, right? We know this thing. Into state store, it has three informations: your start time, your window end time, your message, and your count. We know this thing. Now, if we define the watermark, what Spark will be doing for us, it will be maintaining one virtual column here, and I don't know how it maintains. Let's say watermark. And in this watermark, what it will do, it will compare the window. For example, the first window is 12 to 12:10. Into this case, the watermark is 12:40. And what it says, if every window which is lesser than this particular watermark, remove them. So 12 to 12:10 will be gone, 12:10 to 12:20 will be gone, 12:20 to 12:30 will be gone, right? And 12:30 to 12:40 will be gone. So these 4 windows will be gone since our watermark will be this. So I think that watermark is very clear to you guys. How watermark is created? The formula is very simple. The formula is max event time minus your watermark duration or watermark definition, whatever, right? So into this case, let's say max event time is 1250, and your definition into watermark definition you have mentioned 10 minutes, so it will be coming to 1240. So it means any event which is earlier to this will be discarded, right? So now let's see how watermark is defined onto the Windows operation. So if we go here, and if we go here, so how to define watermark? Watermark will be the first operation before your grouping by operation. So watermark should be the first operation. That's the first condition. Watermark should be the first operation, and it should be on the same column on which your window is defined. So if you see here, I have defined watermark and windowing on the same column, and this is the duration in which I can entertain the late coming events. Okay, so I want my Spark code to entertain only 10 minutes late event. Okay, let's see now. One more thing, watermark won't work with complete mode, and there's a reason behind it. Because if we maintain everything, if you see again, Spark cannot do the contradictory thing. One, if it is complete, we are telling Spark that okay, maintain everything, and at the same time we are telling okay, Spark delete something. So Spark will confuse, right? And that's where it will give some error. So we need to give update mode here or append mode here. So let's give update mode here, and let's see one thing. Let's change this directory and let's run this code. Clear this console and let's run it. So now let's do one thing. I will quickly tell you now. So it is reading from this particular console, and let's go here. Let's go to our watermarking slides, and since this is update, I will do one thing. Let me copy the same events, okay, quickly. So let it generate the first empty event. It generated, it means it is good. So now let's do one thing. Let's paste these events. So we have pasted cat and dog. So it should give me first cat, and then it should give me dog, because obviously it's in update mode. It will always give me the events which are updated, okay? So it give me cat and dog. Perfect, it's working perfectly fine here. And now let's go to see the 12.7, okay? So from 12.2 we went to 12.7. So in this case, the cat should be 2, right? So let's see here quickly. So cat should be 2 here. So cat is 2 now, right? And now let's understand one thing. So till now, what is the watermark? Okay, so we have reached till here, right? We have reached till this event. So we know that first we gave these 2 events. So watermark should be 12.2 minus 10, that is 11.52. It means it will accept every event which is after this. We passed 12.7, so it means 12.7 is after 11.52. So it is accepting it, right? But at this point of time, it will calculate the watermark again, because 12.7 is greater than, it is latest. It means it is the max event. So what it will do now, 12.7 minus 10, it is equal to 11.57. So it will now accept every event which is after 11.57, right? So now let's say we pass one more event, which is before 11.57, right? So let me pass one more event. So let me generate one event for you guys. 1 second. Okay. So let's say, in fact, let me do one thing. Let me update the watermark for 12.13. So what I'll do now, let me update this. 1 second. So let me update this message by dog, and it should create a new window for me, right? Here, it should create a new window for me. And let's see. So basically, I'm just updating the watermark. So in this particular thing, what is the watermark now? So it updated the window from 1210 to 1220. And what is the watermark now? So in this particular case, 1213 minus 10 is equal to 123. 123. So it means any event which is coming after 123 should be entertained. So let's say, now this is interesting. Now let's say this particular event came now. 12.2 event came now. So let's see if it is getting entertained. Okay. So let's run it and let's go to our console. So what it says, okay, basically let's do one thing. I may miscalculated the watermark. What I'll do now, I will say one more thing. So let's say I want to update the watermark again, okay? So I'll pass this event again. So now what it will do, it has updated this 1210 to 1220 window, but now the watermark is 1206, right? 1206 because 1216 minus 10. So let's say now we pass this event again. Now we pass this event again. Now in this case, it should not update it. Why? Because watermark, this should have been deleted from the dictionary. So let's see. Perfect. So what we see here, 1 second. 12 to 1210. 1 second here. So what we say that your watermark is 10 minutes and your, so basically how it is updating. Okay. Because it is basing your events on Windows. Let me see quickly now. So let me say, let's say I'm going to extreme now. So let's say this new event came at 6:13 after 6 hours. So we turned our window after 6. So it means we jumped 6 hours ahead. Okay. So we hit enter. We go to application. It generated a new window 6:10 to 6:20. Now let me send this event again, which arrived 6 hours late. Okay, 6 hours late. So now what it did, okay, now this works. Basically I was not calculating the watermark properly. So what it did, after 6, it created one window for this event, right? It created one window for this event, 6 to 6:20, right? 6:10 to 6:20, and then I gave late coming event. And since Spark has deleted that window because of watermark activity, it haven't updated anything. This is how your watermarking work. Okay. So what watermarking is? Watermarking is nothing but a method by which you can entertain your late coming events. You can define how much late coming events you can entertain in your application. Now there are few conditions on watermarking. Let me read it for you quickly. So what watermarking says, that your output mode can either be append and update. It cannot be complete. Your watermarking column and your group by column or window column should be same. And your watermarking should be the first operation before the aggregation. So 3 conditions you need to satisfy: that your output mode can either be update or append. It cannot be complete. Watermark should be the same column on which your group by or your windows have been defined, and watermark should be called before aggregation. This is good. So this is how watermarking works. So we know what windows are, what watermarking is, how state store is maintained, different kind of stuff, right? Now, one last operation which I need to show you guys is joining. Okay, so now before we jump to joining, let's do one thing. So let's understand joining in this way. So when we talk about Spark streaming joining, so we talk about 2 types of join, right? Since we are talking about streaming, So this is a stream. Either you can join your stream with a stream, or you can join your stream with some static table, or you can join your static table with your stream. So these are three scenarios which are possible when you work with Spark Structured Streaming Joining. So let's focus on this particular section first, which is the most easy to achieve. So in this case, we have one static table and we want to join it with streaming application. Okay, so let's see how it's working. Before even one more thing, right? Whenever we talk about joining, and I have explained it in a lot of details, whenever we talk about joining, we need to know two things, or Spark needs to know two things. For example, if we are going for right outer join, even let's say we are going for inner join. So Spark needs to have two tables. One is your left table and one is your right table, right? And from these two tables, it should know from where we need to compare. Let's say, if I'm going for inner join, it needs to know that which rows from this table and this table are equal on certain condition, and it need to return those rows, right? So it means, what I'm trying to prove here, that Spark should know that some static data from where it need to compare, right? So what Spark streaming says, that when you are doing stream to static table join, you need to keep this thing in mind, that inner join, it's fine, because what Spark says, that if you are going for inner join, let's say streaming with static, right? So let's say we want to implement this streaming with the static. So streaming means one row is coming at a time or two rows are coming at a time, and we need to compare it with some table. So it means we have one database or one table which is static. Now let's say this row came, we can compare it to this and I'm importing or implying inner join here. So once this row came, we'll compare it here, and if it is matching, we'll return the rows. If not, we won't be. So let's say this row matches. This is ABC, and here we already have ABC. So we will return ABC here, right? So what I'm trying to prove here, that Spark needs one data frame which is kind of static, from where it can compare the data, right? So in static, when we are going for static table, this condition is easily applicable, okay? And that's where it's easy to join those tables, okay? So now let's jump to here, in which we want to join batch table with a streaming application, right? So what I did here, again, the same thing, I imported something, I created my Spark session, and I'm reading from some port. Let's say into this case, what my port is. Let's say I want to read from this port itself. Even let's open this port again. So I want to open this port 6466, right? So let's update this port 6466 here and save this. So what I'm doing, I'm reading one stream from this particular socket, from this port, and I'm giving it some structure in the same way I have explained it again in the previous session, and I'm creating my static data frame, okay? And I'm creating my static data frame as this. Okay, so my static data frame is created, nothing very fancy, the same thing what we did in the windowing operation. I created in the same way my static data frame. Now, no, I got confused. So basically, the same way I was creating the streaming data frame for word count program, I created the same way. So what I did, I read from the socket, I define my structure, right? I define my structure, I read the column value, I gave some assign the schema to it, I selected all the columns and I assign it to streaming data frame. Still here we are simple, right? Now what we did, we need to create one static data frame. So what I did here, I read one file which should be here. One second. Yeah. So what I did, I read one more static data frame, nothing but I read the JSON file. Now let me show you what I am reading as a static data frame and what I will be passing in dynamic data frame. Okay, so let's show here. So let's go to your joining here. In fact, let's go to your watermarking. Okay, so what I'm planning to do and what I'm implementing, this is your static table. So in your static table, I have 3 columns. One is your, in fact, 2 columns. So this is, let me show you in here. So this is my where I'm from, a country, right? So let me open country here. So here, this is my static table. So inside this static table, I have only 2 columns, country code and country name, right? So this is my static table. So now I just read it as a JSON and I've assigned this to my static data frame. Now what I'm passing this particular events from my streaming application or from my socket. Now what I need to do for this country code, I need to join it with this country table, and I need to give the country name. So for this particular case, when I'm passing this from my console or from my socket, it should match with this and it should give me United States. Okay, so if I go to my code, what I did, I defined the static data frame and I'm reading country.json here, and then I have joined my static data frame, that is my country.json file, with my dynamic data frame, right? With my dynamic data frame, that is my streaming data frame. On which column I have joined? I have joined on country code, right? So this is my joining condition. So what I did, from static data frame, take the country code. From streaming data frame, take the country code and do the, I don't want the left for now, I want the inner join, let's say. Okay, do the inner join. And at the end, what I'm doing, I'm just updating, I'm printing that on my console. So let's say this is my new directory. So let's run this. Let's stop this for time being, clear the console, and let's run this. So Scala application. So basically what we learned so far, that we can join static with the stream application, but static table, that is your default table, should be either in the, it should be on, in the inner join, it can be anywhere, but in the left join, it should be on the left side. Let's say what I'm saying, but I'll explain in 2 minutes. Right now I haven't passed anything. Let me pass this row. Let me pass this row, and I'm passing it here. So the country code is 10, and it should match the country code. What it did, it read the data from my stream, it matched the data from my default directory from here, right? And it did all the work for us. Now, if I pass one more row, which is orphan or which don't have any country code, what it will do, it won't be telling us everything, rather than it will give us entry, because this is inner join. This is inner join, right? Now, the question is, okay, this thing is clear that inner join is very simple to achieve, but we need to have one static table, and that table should be static, right? Simple. Now let's see if we can go for left join. Let's say if we can go for left join. So simple, we can say here left. So how left work? Left table should be here. So left means what? The left table to the join operator is left. The right table to the join operator is right, right? Now let's run it. Let's see if it is working. So let's see. So basically what I'm saying, that take everything. What left join means? Left join means that give me everything from the left table. Okay, this is perfect, right? So what it says, this is what I wanted to prove. Left outer join with the streaming data frame on the right. Okay, in simple terms, let me copy it and I'll explain it in simple terms. So let me paste it here. Okay, so right now what we are doing this. Let me just copy this part. So what we are doing, we are joining our static data frame, which is your left table, to your right data frame. That is your, this is what we're doing. So this is your left table, this is your right table. Now what, and we are implementing here left outer, right? What left outer says? Left outer says, give me everything from left table, and everything means all the matching rows from the left table, and for the unmatching rows, put none. This is what left outer says, right? So let's say we have table A and table B, and here we have keys 1, 2, and here we have key 1 and 3, and we say left join here. What it will do? It will say 1 and 2, and let's say here it is ABC, and here it is XYZ, whatever. It will say X by YZ and ABC. For 2, let's say here it is 1, 2, 3. It will say 1, 2, 3, and here it will put null here, right? Because for 2 it haven't matched anything. This is how left join works. So what we can see here, that to left join to work, we need to have this table known before we perform the join operation, right? We need to have left into your left join. When we are performing left outer join, we need to have the right table known beforehand, so that Spark or your SQL engine will come to know which rows we need to put null, which rows we need to put value from the right table. What we did here, we are implementing left join. Left join means we need each row from our static table, but we need to match the common rows from the right table, which is your streaming, and we need to put null, which is not matching rows, right? Now the question is, do we know what is coming in streaming? Do we know? Nobody knows, right? Because streaming is real-time dynamic data. So we don't know what is coming in streaming. That's where Spark gave us some error that, okay, guys, I don't know what is coming. So how can I define the left join, right? I don't know what is inside this table. I don't know what is inside this table, because this table is streaming. You made this table streaming. This is dynamic, and I don't know what it is. So either you change the join type or make this table as static. You need to do two things. But one thing is very clear, this is streaming application. We cannot make this static because this table is already static. So now to make this work, we either need to change this to right join now. So let's change this to right and let's run this. So into this case, how right table will work, how right works, that this is your join, this is your left table, this is your right table, right? So now what we did, how right join work, give me everything from right table, give me everything from right table and all the matching rows from left table. So it means left table into this right outer join should be known before. Right outer join, in right outer join, the left table should be known before, because we need to know which rows are matching and which rows are not matching, right? So into this case, into right now, we have this table is static. This table is static, so it should not give us any error. Perfect, it worked. So it means it is working. So now let's say we are giving this particular event. Okay, so let's give this event. It is matching. It should give us something. Let's say what it is saying quickly. One second. Okay, so let me do one thing first. Since I changed the join type, I need to update this directory. So let me update this 18. Okay, because obviously my offsets, my checkpoint directory is still pointing to right application, right side or left side join, whichever is applicable first, right? So one thing is very clear. One thing is very clear that, and let me put it here. When you are implementing left join, then your right table should be static, right? Opposite tables should be static. Obviously, when you are implying right join, then your left table should be static, because right table should be knowing which table is matching, which rows are matching. When you are implementing inner join, then any table should be static, either left or right, any table, right? So this is what we did. Now this is working, and let's paste that row again here quickly. So it should matching. It is matching. Perfect. Now let's do one thing. Since this is right table, and let's give one orphan row here which don't have any row. For example, 56. I don't have 56 country, I know. So let's do. Perfect. This is what I wanted to prove, right? So what it did? It performed the right join. It performed the right join. Now what it did actually, so let me show you the code here. So into this case, we have left table before, like Spark knows what's there in left table because this is static table. Now we are passing something streaming onto the right side. So what we passed 56 here. We passed 56 here, and Spark beforehand knows from the static table that 56 is not available into your static table, and that's where it gave null here. And see, it's not rocket science. So in static join, we need to know what is available in other table, right? And this is what Spark is doing. Now, if we want to make this work as left, let's say if we want to make this work as left, then we just need to switch this. We need to take this here and here and bring the static table to the left. As simple as that. Simple, right? And we'll change the checkpoint directory, Control S. We'll stop this and let's run this. Now let's see how it works. So let's clear the console. So what we know, that to implement the left join, we need to have the right table static, because obviously right table needs to be known before which rows are matching. To implement the right join, we need to have the left table static, because we need to know what is there in the left table so that we can see which rows are matching. So now since we are implementing here left join, let me pass 56 here again. Okay, this is not copied. So let's do one thing. Let's go to your watermarking and let me copy this part. Copy. Let's paste the matching rows. So let's paste it here. It's not copied, sorry. So let's copy this. And let's paste it here. So I'll paste it here, 11, and it should give me India. Perfect, it's working fine because obviously that's matching, right? And let me paste it again and write something here which is not matching. I know I have only 5-6 countries defined. If I say 54 here and I'll pass it here, what it will do? It gave me the same thing with country code and country name is null. So this is how left join is working. Okay. So now we know in the streaming and static table joining, one table needs to be static and that table needs to be at the opposite side of the joining operation. If it is left join, then the static table should be on the right. If it is right join, then the static table should be on the left. Okay. So this is your static table to the streaming joining. What is the other join? The other joining is streaming to streaming joining. Okay. So one thing is very sure. One thing is very sure that in static to streaming joining, we have one table static, and that table needs to be on the opposite side. If it is right join, this table, static table, should be, if it is right join, the static table should be on the left side. If it is left join, this should be on the right side. Simple, right? If it is inner join, it can be anywhere. We know this thing. Now in streaming to streaming join, how things work according to you? Streaming to streaming, we need to make sure, see, streaming means what? These events are coming on real time, these events are coming on real time. We know this thing. Now, how Spark is making sure that this event is matching with this event? Because obviously, let's say this event is ABC, and we want to match this ABC event. This is your left table or left stream, this is your right stream, right? We want to match this ABC with your right stream, and this ABC event is still not arrived. It's still not arrived. This is dynamic, right? So let's say this event occurred at 12:10, and at 12:10 ABC haven't arrived in the right. Makes sense? And here ABC arrived at 12:11. Then one thing we need to make sure, how long we need to wait. And again, and when we're talking about how long we need to wait, once this question arises, we have already explained in the windowing operation. Once we talk about how long, we talk about watermarking. So what it means, and Spark streaming says, Spark structure streaming says, if you want to join streaming with streaming, you need to define the watermark first, so that at least I can wait till that time to match some events, you know. So this is what it is defined into streaming and streaming. So what I did here, the same application I want to show you here. So what I did in streaming and streaming, I'm reading both streams from socket. So I'm reading from, let me change the ports quickly. So this port is, let me open one more port here and copy the password, and I'll paste it here. So I need to create two sockets, right? So that I can create two streams. So this is my first socket, let's say, which is on 6466. And let me open one more port here. Let's say 6476. 6476. So I have two ports now, two streams. One stream is coming from 6466 and one stream is coming from 6476. Okay. So what I did here into my code, let's update this. So I'll say 6466 and 6476. Okay. So now one thing which we need to see here, that from 6466, I'm passing country code, only with country code. From 6476, I need to pass all the country, it means country name and everything. Okay. And then I'm just assigning schema and everything, what we did. And here what we did, we are updating the watermark. So what I say, any event, if you don't find the match, just wait for 10 minutes, then discard it. Just wait for 10 minutes, then discard it. Okay. This is what watermark says. And then I have implemented the inner join, and then I'm writing it on console. Let me update this as well for 2 minutes 29, and let's run this. Let's run this. Let's see if it is working. So we are implementing inner join. We have implemented the watermark. Watermark says just wait for 10 minutes. If it is not there, discard it. Okay, let's see. So watermarking means just maintain the state store for 10 minutes. So let it run. And what we need to see, that on 6466, we need to pass the country code. 6466, we just need to pass the country code one. So let's go to a note, And let's go to your watermarking. Yeah, so here on 6466 port, we need to pass this event because my structure is defined there. So this is 6476. So I need to pass here this code. So that's it. I passed this event. So I passed this event, right? And since there's no match because the other stream we haven't passed anything, so it is null. So what we passed here, we passed country number 10. And let's say we pass the matching event onto the other stream. So this is our other stream. And let's say we pass, sorry, let me copy this again. Okay, sorry, something is going wrong. Control C. Let me say if it is working. Don't worry. Okay, perfect. So let me pass here the matching stream. So when I say here and hit enter, so if I go to my code and let's wait for 2 minutes. Let's wait for another event. So what I passed here? I passed here 10 and I passed here 10. So ideally I passed both 10. It should match. So let me see quickly. So what I defined here, country code DTL should be equal to country code. So country code DTL should be equal to country code, and then I'm watermarking it on CDTL, and it should be fine actually, to be honest. Let's see. Let me paste it again. Let me paste this event again. No, it's not matching. 1 second. Let me stop this application. And let's do one thing. Let's do one thing. When I'm saying here joining condition, so when I say CDF dot join this on joining condition, let me define this condition like this. I'll say this dot call, and in fact Control Z. Let me. So basically, what we were doing, we were joining streaming and streaming, right? So and I was explaining it to you that when we want to join streaming application, we need to give watermark on both the streams. So now we have two streams. We have two streams. One stream, in one stream we are getting this data, that is this data, right? And in the other stream we are getting the detail of the countries. For example, in the first stream we are getting country code. In the second stream we are getting country code plus country name with the event time. Okay, in both the stream we are getting the event time. So what we did here in the code, that we read both the streams, right? Country code stream and country detail stream. We define our struct field, right? And then what I was saying, that we need to define the watermark when we read the data from streaming application, so that Spark can decide how long it need to wait for, how long it need to maintain the state store. So we define the watermark for 10 minutes, right? And then we define the joining condition. This is join DF. So we define the country detail and country code. We join on country code, right? And the join type is inner. And then we are printing that onto our console. So let's say we change the directory and we run this application again, okay? And let's pass this. So what we need to make sure that on 6466, we are passing the country code data stream. On 6476, we need to pass the detail one. So let's copy the 64, the data stream between which you need to paste on 6466. So this is what 64, where we open this is 6476. So we need to paste this country code here, and let's paste that here. And we haven't hit the enter. Let's wait for the first. Okay, this is coming now. So what we do here, we'll go here and hit enter. So our first stream for the country code came. Now we need to paste one more stream for country detail. So let's say we are pasting this stream, right? And 6476. This is your 6476, right? 6476. Let's paste that event here again, and let's see if it's working. So the 2 batches occurred, and let's see the 3rd batch. Okay, so it is working. So what we see that if we want to join a stream with the stream, then we need to put the watermark on the streams, on both the streams, right? If we are working on inner joins. Now there, when we want to work for left outer, right outer, there are other condition. I will explain those condition in theory, and you guys can implement it if you want. Okay, so this is what your support matrix for joins looks like, and I'll jump to streaming again. So for inner join to be implemented, what you need to say, it's supported, like inner join is supported, and I have proved it to you guys. And you need to optionally specify watermark on both sides and time constraints for the cleanup. For the time constraint for the cleanup, I'll tell you now in 2 minutes. But when we talk about left outer join, then it is conditionally supported, and the same condition will be applicable here. For left outer, your right table should be known before. So what it says, your right table must be watermarked, right? And time constraint for the correct result, that should be there. For the right outer join, your left table should be watermarked, right? Because your left table should be known before. For fully outer join, conditionally supported must specify watermark on one side and time constraint for the correct results. Left semi is also supported, but what I want to prove you here, that left outer, right outer, we need to put the watermark on the opposite table. Okay. Now what this condition is. Watermark is good, we are defining the watermark, but what this condition is, time constraint for state cleanup. So obviously watermark will do the state cleanup. What this condition is, how long it need to wait for the events to come. So watermark is for state cleanup, but how long it need to wait for other side event to come. For example, let's say at 12:05 we have country code 10 came, and at 12:15 we have detail for this 10 came. So if we have 10-minute duration for the max time here, this one, time constant for the correct result, then the result will be arrived. But if this came as 16, and if this max time has been passed, I'll show you how we need to define, then the result won't be showed up, even though your state store is not cleaned. Okay, so define that condition, you need to tell something like this. Yeah, so into our case, we have e-date, right? E-date. So what we say, that on the joining condition, paste this thing, Control C here and Control V. What we need to say on the joining condition, that okay, map the country code from both the tables and the e-date between e-date from the other table, that's a CD table, and plus 10 minutes. So what we are showing here, let me do it quickly. So the e-date, that is a timestamp of one table, should lie between some predefined time interval, which is 10 minutes from now, kind of this. Okay, and this is the same thing what I've explained here. So this is how your joining works in static and streaming application. So let's cover it quickly. In static and static, all types of joins supported. In stream and static, inner is supported, and it do not need to be stateful, right? In left outer, it's supported, not stateful. So it means your right into left outer, your right table should be static. Right outer. Okay, so when your streaming is your left input, right? Then obviously right outer is not supported. It's getting confused, complicated, but the same theory what I've explained in past should be applied here. Okay. So I think this is all for Spark structured streaming. Tomorrow we'll start the Kafka topic. Okay. Thanks everyone.